Welcome to the Ultimate PCB Design Masterclass, where you'll learn how to craft professional-grade circuits for guitar pedals from start to finish. In this comprehensive course, we will do a PCB design for the classic Marshall Shredmaster, starting from a circuit schematic found online all the way to a professional PCB ready for manufacturing. This is a practical tutorial that follows the exact same process I use professionally for designing more than 320-plus pedal circuit boards. For today's tutorial, we will be following the schematic for the Marshall Shredmaster. However, here we will cover the basics so you can follow along with any circuit of your choice. Just bear in mind to start with something relatively simple and with similar structure to the one in this tutorial. So don't go full crazy on transcribing an analog delay with more than 120 components. Let's keep it easy for now to ensure your first design will be working flawlessly. For more advanced builders, I recommend you as well to take a look at our EAGLE Gerber pack. With all the 320-plus designs I ever made, link in the description below. So without further ado, let's begin learning how to design guitar pedals. This tutorial is structured in 5 main sections. Section 1, Schematic Reading, Fundamentals. I'll teach you how to decode circuit diagrams, identify component types, and understand the signal path through a guitar pedal circuit. Section 2, Schematic Transcription. We'll take the Shredmaster schematic and recreate it in EAGLE CAD. You'll learn proper component selection, library management, and schematic best practices. Section 3, PCB Layout Design. This is where your circuit becomes real. I'll show you component placement strategy, routing techniques, ground plane creation, and layout optimization. Section 4, Manufacturing Preparation. From adding your branding to generating Gerber files and placing your first factory order, I'll show you the complete production workflow. Your learning outcomes. After completing this tutorial, you will be able to confidently read and interpret guitar, pedal schematics, perform basic circuit modifications and improvements, transcribe any schematic into EAGLE CAD software design, professional-grade PCB layouts, add custom logos and branding to your designs, generate manufacturing files, and order from factories. What you'll need: EAGLE CAD, free version works fine. The Shredmaster schematic, link below, or any schematic of your choice. The PCB Mania component libraries, installation guide in the description. About a couple of focus time. Let's begin with schematic fundamentals. What is a schematic? A schematic is like a map that shows how electronic components connect together. Instead of showing what things look like physically, it uses symbols to represent each part and lines to show how electricity flows between them. Basic components. Nets and paths. Lines on a schematic represent wires or connections. When lines connect, electricity can flow between those points. A dot where lines meet means they're electrically connected. Lines that cross without a dot are not connected. They just pass over each other. Ground, GND. The reference point for all voltages in the circuit, usually shown as a triangle, lines, or the symbol. Think of it as the return path for electricity, like the negative terminal of a battery. Multiple ground symbols on a schematic are all connected together. Voltage references, VB, VA, 9 volts, etc. Labels like VB, VA, or 9 volts indicate power supply points. These provide positive voltage to power the circuit. The voltage is always measured relative to ground. Same labels equals same voltage point, even if drawn separately. Passive components control and shape electricity without needing power supply. Resistors slow down or limit the flow of electricity. Symbol, zigzag line or rectangle, resist the flow of electricity, measured in ohms, omega, kilo-ohms, kilo-omega, or megohms, mega-omega. Used to control current, set volume levels, and protect components. Values shown like 10, K equals 10,000 ohms. Potentiometers, variable resistors, adjust how much electric signal flows while turning a knob. Symbol, resistor with an arrow pointing to it. A resistor you can adjust by turning a knob. 3 connections, 2 ends and a middle. Wiper that moves common labels. Gain, tone, volume. These are your pedals knobs, measured in ohms like regular resistors. Capacitors store and release electricity to smooth or shape signals. Symbol, 2 parallel lines, sometimes one curved, store and release electrical charge. Block D, C, constant voltage, but pass A, C, changing signals like audio. Measured in farads, F, usually microfarads, nanofarads, or picofarads, used for filtering and tone shaping in guitar pedals. Active components use power to control, boost, or switch electricity. Diodes let electricity flow only one way. Symbol, triangle pointing to a line, like an arrow. Allow electricity to flow in one direction only. The arrow shows the direction current flows, used for protection and signal clipping. Distortion, LEDs, light-emitting diodes. Glow, to show current is flowing, symbol. Diode symbol with small arrows pointing outward, like a regular diode but emits light when current flows. The indicator light on your pedal that shows it's on must have a current limiting resistor or they burn out transistors. Control current flow, act as switches, and amplify signals depending on how you apply voltage. Symbol, varies. BJT has arrow, FET has different style. Amplify signals or act as switches. 3 connections, usually base/collector/emitter or gate/drain/source. Think of them as tiny volume knobs controlled by voltage, common in overdrive and distortion circuits. Integrated circuits, ICs- contain multiple electronic components in one chip to perform amplification, switching, or signal processing tasks. Symbol, rectangle or triangle with multiple pins. Complete circuits packaged in one chip. Pins are numbered. Check the datasheet for functions. Common in pedals. Op-amps, operational amplifiers, for boosting and shaping sound. Examples, TL072, JRC4, 558. These amplify your guitar signal. Input-output connections. Input-output pads, labeled IN, OUT, INPUT, OUTPUT, or similar, where your guitar cable connects, input, and goes to the amp, output, sometimes shown as connection points or jacks. These are the starting and ending points of your audio signal path. Reading the flow, find the input where your guitar signal enters. Follow the path through capacitors, tone shaping, resistors, volume control, and active components, amplification clipping. Watch for potentiometers. These are adjustable controls. Track to the output where the processed signal leaves. Note the power supply connections and ground points. Pro tips for beginners. Trace one signal path at a time. Don't try to understand everything at once. Component values matter. A 100,000 ohm resistor behaves very differently than a 1,000 ohm resistor. Think in stages. Most pedals have input buffering, tone shaping, amplification, output. Ground is everywhere. Don't be confused by multiple ground symbols. They're all the same point. Data sheets are your friend. Look up IC part numbers to understand what each pin does. With practice, reading schematics becomes second nature. Start simple, follow the signal, and soon you'll understand how your favorite pedals create their unique sounds. Now, let's begin with the transcription of your first schematic.
The Shred Master. It's going to be a basic tutorial on how to copy a schematic and how to do the PCB design. So first of all, we start here in the Eagle. We go to Manage Libraries, Use None. Here, we check PCB Mania libraries, use all. I have a quick tutorial on how to do that in a PDF sheet that I will link in the description below. So yeah, now if you can see here, we have all the parts that we're gonna need. This is a filter selection of components and parts. That is the one that we always use. So we're gonna start with the input on the pad that we always use. I call it a good one because there were many variants, and now I just sum it up to use this one. So I normally add a bunch of them so we can have them for later. Here I did a double one, so yeah. Screw that thing up. Okay, so then we're gonna proceed to add the resistors. We always gonna use the same type of resistor that we have here. This is R3B. All of them are useful, but they have different footprints. This is the standard one for most pedals. So we place here the resistor pull down, and I'm gonna drop this one here for future reference for this voltage reference one. We go for capacitors, film, and we're going to use 5 millimeters, same as before. This is the one that's most convenient and standard use for most pedals. So we place that here and we start drawing the nets. Always start from the component and make sure you're going to go through the other component that you have that circle or that junction is created. So then we have that. Now we're going to go to supply pins. We're going to add the two things. We're going to add first the GND, the ground here. Always make sure that it's connected when you do that. So yeah, it's connected. And now we're gonna add the voltage reference. So we have that thing here. We will proceed now. If you ever find that this is getting messy, just go to search and push enter, and then you will be back to everything clean up. So now we're gonna go to integrated circuits, and we're gonna add the dual op amp that we have here. Again, we have like many different footprints. We're gonna go for the classic standard issue here. And an op amp is composed by 3 parts. So there we place the three parts: first a pump, second a pump, and the power rails. As you can see here, we start with the signal goes into the positive input. So for that we need to use the mirror tool here, and then rotate as we have here. We just connect the nuts, the nuts. There we have it. Okay, so always good to be saving your work. You don't want to get lost by any mistake. And yeah, now we can use the copy tool that we have here just for drag and drop the next capacitor that we need. And yeah, can always make some adjustments here, so because I know how it's gonna end up this looking later. We're gonna go for the potentiometer. We're gonna go here, the 60 millimeters. I go for the C mount, the center mount, and yeah, we got here. Always make sure that the pinout matches. This is a schematic that I got from Reddit. According to what was talking the thread, it was verified. So yeah, I have seen Shredmaster schematics before, and yeah, looks legit. So then we proceed with that. I'm gonna just drag this stuff a bit up just to give more space. I'm gonna fix this thing just for aesthetic purposes. That's all. We're gonna copy also the ground. So you can see this section I'm doing here, I'm doing it a bit differently. It's the same thing. As long as the nets are connected properly, it is the same how you do it. Also, another thing, as you can see here here start like 5, 6, 7 pins, and here we're in 3 to 1. This is something that is the same in the case of dual pump, and it could be very easily modified later on the circuit design stage. So we keep on here. Here we have the same thing as before, that the op amp is inverted. I like to add a grid here, just for keeping things tidy. Again, we use the voltage reference down below here. As you can see, this process is quite easy to do. Great. So a couple more capacitors and things, and here we are. There we have. This is looking fantastic. Now this section that we have here is not typical from the Shredmaster. This is really something that the person who transcribed this schematic adds. Shredmaster have like only two LEDs, and this is like an added clipping toggle. So yeah, we can add it just for the sake of it. It's not. It depends on the model. It's always better for you to try and experiment, but I believe that the diode toggle doesn't hurt any pedal. In fact, it adds more versatility. So yeah, I like to use these ones. Let's point two. It doesn't matter here the order because again it's the same net. So yeah, it will go well either way. So just fix this thing here. I don't like how that looks. Sorry, that was just my OCD doing a cosmetic adjustment. You can always do right click here on add component and just select from the previous use component if you don't want to be going back and forth looking for the component you just used. Okay, now we're gonna add those extra diodes that the designer of the circuit did. We're gonna go for the basic diodes we have here. You're gonna use these ones. Always check the package that fits the better for your needs, right? Not don't take what I'm doing here as gospel. So the diode configuration in this circuit is actually a bit interesting, like because here in the what we're going to be doing with this toggle. Okay, I just want to add one layer here so we can have some symmetry. Yeah. And the toggle. We go here to switches. SPDT again, and I like this one. This one is PCB mounted. So here we can choose which extra set of diode we're gonna use for this project, and we copy the voltage reference. So what this toggle does here, like we're gonna use an SPDT on of on. Actually, it will be a good reference to add now. We're gonna call this diode switch, and on the value we're gonna add that this one is on, off, on. That way we're gonna have, when this switch is in off mode, either of these set of diodes is gonna be, neither of these set of diodes is gonna be engaged. So we're gonna just keep the default LEDs. So all right. So let's go on now with the EQ section that we have here. Remember, we can always go back here to select from the previous components that we have been using. And yes, let's add some capacitors. Here I'm just like roughly placing them. When I place the potentiometers, always make sure the proper pin out of the potentiometers, otherwise you're gonna end up having with uh, a reverse pot, and we don't want that. So yes, here we have it. That's good. Okay, for aesthetic purposes, I'm just gonna this one here and this one here. Duplicate this spot here. Here. Again, you don't need to know much about circuit design for this. I mean, like this is just like transcribing in a schematic. It doesn't have much more than that. The more you start doing it, the more you start seeing a schematic, you're gonna start noticing patterns. Like for example, here it would be very easy to add a 3-band tone stack. Maybe I will do that later at the moment of the of the PCB design, if I feel like it will fit properly the design. Well, let's see how it goes. Also, it would be good if we just like change the name of the pods, because why not? We add some order. So yeah, this R2 is the the one we use for the stuff. Okay, so now we need to add another op amp. So yes, I think we need to go back. You have to integrated circuits, dual op amp here. All right, we're half the way through this circuit, so everything is looking smoothly. Again, we flip it and we mirror it. So there we have it. It's going on here. And again, I forgot here in this case to use the other parts of the thing. So right click here. There's a very important step. Don't forget about invoke. And here we're going to be able to call the missing parts. So yes, it's always sure that you have your op amp complete and that it matches the amount of op amps that you need for this circuit. Otherwise, you're gonna end up having multiple op-amps that are just using one section, and when you are designing the PCB, it's gonna become very, very nasty. Okay, so for example, here's some little things that you can save some work. As we can see, this figure here is exactly the same as we have here, except with except by the values, of course, and the pot. So if you're feeling like you just wanna do this, you can just select this part, copy it, Control C, and just paste it here. Now we're gonna delete the pot, of course, because we don't need a pot there, even though it will add like as another extra gain control for that stage. But I don't know if we need it. I don't know if we want it. So for now, it's better if we just delete it. But here we have a little detail that we cannot avoid. That here we're taking this to GND, and here we're taking it to the voltage reference. So we just copy the voltage reference here, and there we have it. It's the same figure, it's the same configuration, and we are ready to go on. So keep on adding resistors. Here we have a very interesting notch. I'm just gonna add, I see that there's like 3 resistors in series kinda, so I'm just gonna copy them like this, and then I'm gonna, yeah, maybe I'm gonna add one more. Perfect. And I'll proceed with the capacitors. I think I overdid the, I'm like trying to make this aesthetically pleasant in a way, like so we can keep the order of the things and make it good. Just gonna add this pot too. Yeah, it's gonna do it. Yep. Always make sure that you are using the pots pin out properly. Yes, we can put the voltage reference, but we don't have it, so just copy it from here.
Tracing and designing PCBs can be a lot of fun, but let's be honest. We've already traced most of the pedals you'd ever want to build. Our EAGLE Gerber pack gives you instant access to 320 plus tested, verified models ready to tweak, customize, and order. Save the time for experimenting and tone chasing, not redrawing the same circuits. It's a no-brainer. Get the EAGLE Gerber pack at PCBGuitarMania.com for only $119. Early bird price valid for November only.
And here we have these things done. Good. Here we can place this other one we have here. Again, we must mirror it and rotate as it's inverted. Yeah. And for this section, we're gonna add also this thing here and this thing here. Voltage reference. This is a simple circuit, so we don't have many issues with the voltage references. In some others, like we're using many different threads and things get quite nasty quite fast. But I choose this one because it's one model that we don't have in our catalog. And yeah, it's good. And now we're gonna bring one of these pads that we put at first. Let's hear this ground. Okay, we're gonna change the name of this one to out. And something very important that here we're missing that we don't have it. Oh, it's right here. So yes, we need to add the power section. So I'm gonna grab this one and I'm gonna make it, call it 9 volt, and I'm gonna call this one GND. Actually, I'm gonna delete these extra ones and I will explain you why in a bit. Okay, so we grab 9 volt. We are gonna add polarity protection diode. So normally go for these ones, square one, and we place that there. And we're gonna start placing the capacitors. Let's place this one here. We can add also the electrolyte capacitors. Here, like you can choose the millimeters you want to use, the thickness of the capacitor. Like as here, this is a small circuit. I would just rather go for a big one. So if you have a big capacitor, you can just use it. It would be good. All right, so we connect the nets, and we need these two resistors. And here I'm gonna just change the value of this one because we need to duplicate it. So I know that this one is 47K. I like to keep the K in minus. Always try to keep consistency in the way you label the values of the components. We are gonna add all the values for all the components now. So one thing that we have missing here is the power rails of both of our op-amps, and if we don't connect these, our pedal is not gonna work. Here, the designer connect them here on the schematic. I don't like to do that much, to be honest, because it can be a bit confusing. So I know that this net VA, what's called basically 9 volts, as you can see, it goes straight to the polarity protection diode. This is basically 9 volts. We can just drag this section and place these two right here. I should give them a bit more space. Again, like for making things easier to scan quickly with the eyes. And here we have that thing. We must proceed to add the GNDs for all of these things. It could work with a common GND if you want to. It's the same. You can just connect all the nets there, and yeah. But for again aesthetic purposes, I think like easy to scan through. I'd rather go this way now. At least now. It depends on the occasion of each. Okay, we need another electrolyte capacitor here for 47 UF, and here I'm gonna go for a traditional one because 47 UF is normally a small value, so we didn't have to put that much, that such a big electrolyte capacitor, right? Especially when we're talking about like values that are for pedals. Always make sure that the GND is properly connected. Yes, it is. And we need to add the voltage reference here. Yes, here we have a VA reference that is connected to this power right here. I think there is no other VA here, but just for keeping consistency and to make things good, we are gonna add it. And actually, we're gonna use that for the LED that we're gonna place right now. Yes. Okay. Here with this GND that we have here. Okay, I forgot. Let's go first with the VA thing. Yeah, I told you. So we're gonna add this VA thing. We are gonna add a resistor, normal one of them, here, and we are gonna proceed to add the LED for the status LED. I like to go with this one. It's the clearest for me for using for these purposes. And I'm gonna just duplicate the GND and I'm gonna change the name. So this now is gonna call CTRL. This for me is an acronym for control, and is the one that is gonna do the foot switch to turn on or off the potentiometer. So this normally goes well for a 4K7 resistor, so smaller values will make the LED brighter, and bigger values will make it a bit dimmer, a bit less bright. This is kind of on the blinding side. Well, my kind of blinding lights are fucking annoying, but I love them. Okay, so the last thing, they're gonna just we're gonna need a bunch of GNDs. We're gonna need one for the connected to the foot switch, one for the 9-volt connection, and one for each jack, just to keep things tidy. And yeah, so also to keep things tidy, we go for smash button, click here, here. So, and then we delete those extra names, so it's understood that all of those are GNDs. And we have background control here. Yes. So the skeleton is done. Next step will be to change some values to put the proper naming and proper values. So to finish this, it's just gonna move this to make things more tidy. We're gonna start with the value tool. Okay, so there's no value for the path. This is a name. We call this one in, so it's very clear. We're gonna start with the values. 2 and 2. I'm gonna keep everything on small letters for keeping everything consistent. This is also a good time for, I like to add PF for this one, so let's just clear this before add. So here you have the indicators, the behavior of the body is logarithmic or linear in capitals, so it stands out from the K you have of the value. Yeah, so I was saying before, this is a great time for making sure that all the connections are properly down and that there is no misconnection. I will do that a bunch of times through the circuit to ensure that everything is done right, right? We try to avoid mistakes. I want to have things working at first attempt, right? So now I'm gonna add this TL072. Op amps in this type of circuit are, to be honest, very, very, how can I say, interchangeable. Like you can use a TL072 or a 4558, and the result is gonna be quite the same. Of course, you can say that it's not, but for practical purposes, the pedal's gonna work and it's gonna sound great. Whatever you want to choose there is like fine tuning, let's say. Okay, so the hard clipping, this is yes, it would say like that doesn't have value, but if you want to make it red LED, here I assume will be like a 1N4148. That's the most common diode for this type of purposes, for clipping purpose. And normally in the docs, I recommend people to experiment and to add whatever they feel that they sound the best to their ears. This is about experimentation. Like, and if you're building a pedal that you can buy yourself, it's better like if you should experiment. So here I grab the Smash tool, and the Smash tool like allows us to move the values so we can keep things easy to read. We're gonna do that for all the conflicts that we have here. So we don't want this to be messy. We just want to have it clear and easy to read.
By the way, if you've ever swapped out diodes in a distortion circuit, you know how dramatically that can change the character of the sound. Hard clipping like a Shredmaster, soft clipping like a Tube Screamer, totally different feel. If you want to explore those differences across tons of circuits, grab our EAGLE Gerber pack. It's got over 300 fully built layouts ready to tweak schematics, boards, and Gerbers included. Perfect for experimenting and learning fast. If you just want to get some of our PCBs, check out our official distributors, DazMusicking.com in Europe, HeavyMetalFX.com in North America, and ThereallyGoodPedalCo.com.au in Australia.
Okay, let's keep on adding values. 6K, 8, 22N, 220N. Almost there. Okay, so here, for example, I noticed the first thing that I was missing. I was missing one resistor there, and it's a great catch that we just grab it now, right? Like it's better to grab it now than find later we have a missing resistor. So great, we just copy this one here, and yeah, it's the same thing. Like wherever you want to place it, all the connections are making contact. Just gonna fix this thing here. Can we like just so yeah, R19 is a bit out of place there, but it works well. 120, and we're gonna do some corrections with the bigger values for proper for making the circuit the best circuit board tight as possible. And also 2 and 2, 220K. R 100N, 47N. Yeah. I'm gonna grab all these bigger values like the 22 and above, and I'm gonna replace them for a bigger footprint component. That will make a difference for the proper layout display. Again, I just try to keep this thing tight up a bit. And this 100 and we need to change the name because we just copied these ones. This is called volume. Now we need to go here to the power section. But yeah, so always with polarity capacitors, make sure that you are the proper. I'm gonna put the F there, the proper polarity. So you have 100 and good. And now this one, 1N517. This is the most common polarity protection diode. And here we are. Everything is properly labeled. Okay, as I said before, we're gonna proceed to update the bigger capacitors for proper for keeping things tidy, right? You know what I mean. So as I saw before, we have like this 220N. We're gonna check right click package, and here you can see. Normally the plus this one uh, 0.33 UF plus is the one that is bigger. I mean, as you can see, it's for values that are this will be like the equivalent to 330 nanofarads, but sometimes 220 comes in a bigger package, so it's good to swap it. So you're gonna just like right click, package, and select to everything that we see is 220 NF. That will be good for keeping things good. And there we have it. Ready, we're ready to proceed on generating the board. So we click here. Yes, we want to create the board, and here we have our new workspace. We select all this crap and we just delete it. We go here to add a component, we go to enclosure, and we're going to select the enclosure that we're going to use for this project. In this case, 125B will be more than enough, will be perfect for this type of product. All right, so we proceed to, as you can see here, we have some noise from the other layers, so we don't want to see button names or button values, and that will add much more clarity to our design. We add the grid as well to keep things tidy and well organized, and we start selecting. I always start first with the main connectors and the LED. So we're gonna start with the bottom ones. We have like one serial, GND, and out. Those are the ones I always use for all the builds, and I always place those first. We're gonna fix that later, so no rush for that. And now I'm adding the LED on top of that for making things easier. So we right click here on the enclosure, we're gonna go to properties, and we're gonna lock it. So that's not gonna be annoying if you wanna start switching things around. So second thing we do is start distributing the pots. I like to go following the signal flow. Following the signal flow is one of the most important things to guarantee that our circuit is gonna be free of noise and is gonna be uh, efficient. We're gonna keep short traces and everything is gonna go well. So we start from in and we're gonna go clockwise. We're gonna have first gain, then the EQ section, then this one that is called, like, I forgot to change the name on this one. That one is called contour. It's not the value, it's the, so this one is a 100 KB, and the proper label is contour. So, and finally we're gonna close with volume. So, and in the middle we're gonna have here the toggle switch. As I said before, when I'm seeing this, I'm already thinking about adding a mix control. We're gonna check that in a second.
This schematic took 35 minutes, and we still have the PCB layout ahead. With our EAGLE Gerber pack, both are done for 300 plus pedals. Modify them, add your brand, and send to production. All the work already done for you. Get the EAGLE Gerber pack at PCBGuitarMania.com for only $119. Early bird price valid for November only. And get access forever.
But first, let's go with the distribution of the current components. So, as we have here, as I said before, we're gonna start here with gain. Then we're gonna, the EQ section is gonna go on top. Volume at last. And I like to keep things tidy on the same time, right? Like as I said before, even though contour goes after the EQ section, I think it will be much more useful to have it in a place that makes sense. Like here in the middle, that would be good. But for here the design, we also have the diode switch. Normally, I will place the contour thing here, even though it's not correct, and the diode switch in between. Because remember that here would be good if we end up our board limits up there. I will just show you what I'm talking about in a second. So yeah, I will proceed to organize these things here. I normally like to leave 2 squares space between all of them. It's good if you standardize the component spacing, so you have like much more consistency in what you're doing. But like I said before, I think like this diode switch would be better to keep it somewhere here, and we're gonna add a third pot that's gonna be the mix control. So as you can see here, and I told you earlier, here we could add a mix control, and that's actually what we have here in our JFT 800. As you can see, it's very similar what we have here. So even though the values are different, the structure of the tone stack is quite similar. So we're gonna replace this one for another bot I have here. I'm gonna call it meets new value. We're gonna go first for the name. And the value is gonna be a 5K B. So we're gonna flip that up. And we're gonna remove this connection. Like I said, this is my mod. Feel free to do it another way. And for keeping, actually, I would like here to have let's replace this value. Actually, let's replace this value for a 2 KB. So that way, when the pod it's at noon, we will have the standard settings, right? It's gonna be set up on 1K as it used to be that fixed resistor. So there we have it. That was the simplest mod I could come up with to have a mix control. I think it's gonna work fantastic. And yeah, so we grab this one up, take this one down. Here we have it. All right. So to keep things a bit more tidy, we're gonna pull down all this, and now we're gonna move all of them up one. There we have it. So diode switch is gonna be all right here, and yeah, to be honest, I would like to place diode switch more like in this area next to volume, but here close to gain will go well, and also fits well like the concept of the gain structure. So let's go for the line tool, and we're gonna design the dimension. For having dimension better, I normally like to change the color and like put something that is more remarkable, like orange. So we have a clear view. That's what's going on in the latest Eagle versions. And yeah, you just draw here how long you want to be your board, like in a gross manner. I always do the same dimensions. I always extend over a bit over the dash line, and then I proceed to use the curve, so I can just round the corners of this, always with the spacing of 2. So, I just go 2 above, and then I flip it up. So 2 above, and I flip it up. I delete the accident. I save it. Also, here you can add on the enclosure, you can add the 3PDT just to have a reference on where the main switch is going to go. This will also save you a lot of time and headaches at the moment of crafting the final thing, right? So there we have, like, that's gonna be our maximum board dimension. We want to keep it that way. So we're gonna go here to the polygon tool. We're gonna go to the top layer, and now we're gonna create what's called the ground net. Something interesting that we have in this design is that most of our components are not connecting to ground, but they're connected to voltage reference. In some designs, what I like to do to make things easier is to create 2 RASnet layers, and that's actually what I'm gonna do here just as an example. So on the top layer, we are gonna have this polygon. We're gonna have a width of 10, that's the average that I use. We're gonna use an isolate of 10 as well. Those are the standard values I always use for all my designs. And we're gonna draw this polygon here. Then right click, name, GND. That means that everything that's connected to ground, as you can see here in this thing, we have nothing that's connected to ground so far, but I'm gonna just add 1 ground as an example. As you can see, ground is now connected. So in the red layer, everything that's gonna be connected to it is gonna be connected to ground. So now what we're gonna do is going to polygon again, bottom layer, We're gonna do another polygon, exactly the same values as before. Right click, name. Here we're gonna call it B, because that's the name that we have for voltage reference. So as I told you before, we have a lot of parts connected to voltage reference, and that saves us a lot of nets. So we have top layer connected to ground, bottom layer connected to the voltage reference. I did that in some designs. So it's not something I do quite often, but I want to show you here. I remember doing that on the RAB, on the red, and end up quite goodly. So I place here in the middle. The LED, it's always controversial. Some people like to have it more here on the side. That's up to you. Some people like to use an external port with the LED or a soft relay bypass. Here I'm looking for the simplest common solution. Here, the RASnet is always like what we do to make things fit, to make things are placed and connected to our main core layers. And yes, so I'm gonna do a few updates here just to keep things tidy. I'm gonna go for smash. I'm gonna smash all of these things. And I'm just gonna move them below. So I can also place this thing here. And that way we already start being efficient with the placing. Sometimes for placing that, it's good to change the grid. So I just put 12.5 just for adjusting these ones. That's the only thing I want to do with them. And yes, I will also adjust the size, right click, size, I will place like 35. Yeah, so I will put 35 on all of them. This is a cosmetic that I normally do at last, but I rather today I want to start things clear. That's good. Save it. We go back to normal layer of normal grid of 50, and now we can start placing the components. So gladly in this design, I started placing everything with the proper orientation, so everything is following the order of the clock. This can. And I know already that our design goes like I said, in order. So I know that I can start placing all this section. So I can like from resistor 1 to resistor 4 and capacitor 1 to capacitor 4, I'm gonna place all those now. So I go here, I select all the capacitors I want to move. I'm gonna just drop back those other two then. Sometimes if the yellow layers are annoying you, just go here to unrouted and click apply so you are not gonna see them anymore. And that's good for a while, but then you're gonna need them back. So, and I select this 4. I'm just missing R1. It's here. Right, so now I can go back to select unrouted. We click RASnet, so we make the things proper. And yeah, here what I like to do is to start placing the components this way. So I know how it's gonna be the columns. We're gonna have always the same spacing between all the columns. So this layout is gonna end up looking like this, like having 5 columns of components that ensure like consistency and stability all across the the component, right? The component distribution. So we know that, say before, we're gonna move things to the proper placing first of all. And yeah, they're gonna start placing all these things here. So you can see there are many components that are already wanting to connect to another source. That's perfectly fine. Always click RASnets to have them. with the reference. As you can see, voltage reference is connected properly. And yeah. Don't forget that some of these are already connecting to some other part of the circuit. So it's good if we just keep things tidy and in order. You hear me saying that a lot of times here, like keeping things tidy and in order is critical for this job. There. Okay, so here we see that R4 is connected to that thing and the other thing, and this one is connected to there. Yeah, it's gonna go well. And keep there the same structure as before. We have to remember that we're gonna have a lot of diodes coming here, but we're gonna work on that in a bit. And that's not so critical. I wanna fix this part first, and then we're gonna have the whole set of diodes. And it's gonna have a bit annoying, but it's gonna be alright. So we start drawing the lines. You choose like if you want to start with the top or bottom. I normally go full bottom first. Some people like to use auto router here, but I like to make sure that I'm placing all the components properly and the proper structure and distribution, as you can see here. And yeah, even though sometimes there's conflicting like this one that we have here. So we have here, you see that it's gonna be a bit tricky, but we're gonna handle it properly. So I am already making this thing that seems like a weird twist here, for example. But that's because I know that later on I will need to be placing this switch toggle here, and I'm gonna need to use the red layer, top layer to cross for properly connecting the diode section. So yeah, we have all that done. Now I know that we need C5, R5, C6, and R6. That's all we need. Always click here on Rasen so it will show you what is the next connection node for the desired component. I'll go here first with this one. I really have to take in mind where are the next one going. So yeah. And also I will pull this a bit down, but I know that later I will need this R18 here for the LED, so I'd rather copy that one now. So I ensure that that place is gonna be properly occupied. We need to rush on placing that one. There's plenty of time for that. So yeah, gonna start placing these connections. Sometimes, like when we are so tight, it's good to switch to divide the grid. We have that. It's good. And yes, we are good. So far, so good. I already see that this one will be better if we just place it like that for the proper voltage reference. But we're gonna take care of that later. Now it's time to move on. And we have R6 that is connecting to the diode network. Yes. So there's a lot of diodes that we have here. There's like 8 diodes counting LEDs and counting LEDs. So yeah, it's gonna have to start first. These ones. In this specific project, we have a lot of space, so we can take some freedoms, some liberties that we wouldn't be allowed to do in some other projects. So, yeah.
Complex routing can get a bit overwhelming. If you want to save time and avoid mistakes, check out our EAGLE Gerber pack is already routed and verified. 300 plus designs, including not only the basic and classic overdrives, but all your favorite boutique pedals and complex delay, chorus, and modulations. Build your dream pedals without months of trial and error. Get the EAGLE Gerber pack now at PCBGuitarMania.com, only $119 this November, and it's yours forever. If you just want to get some of our PCBs, check out our official distributors, DazMusicking.com in Europe, HeavyMetalFX.com in North America, and Verily, GoodPedalco.com.au in Australia.
Save. It's always good to have the habit of constant saving, right? And again, like here, I'm trying to keep some cosmetic details, let's say, over. Okay, so I forgot to change back the grid. So it's good to keep things tidy again. It's always important to keep the grid, so otherwise then you're gonna having issues like you're having now. So it's just now, yes, we can go back to normal grid. Good. And we can properly place these components. So here you can always check like where is this one going and to what is connecting. And I think like here, for example, we can just flip this one up. And also we need to make sure where this one is going and where this other one is going. So just flip this. And here we're going to have the first conflict, that is that this line is crossing the other one. So that we need to place a red layer, a top layer. That way, we have no problem. So we know that this one is going to connect there and this one is going to go there. We place this net here. Let's just go there. Again, we need the red because we have this one crossing there, and we need to apply the same concept to this other layer. To this other net, sorry. Back to the bottom layer. Or it's always good if you try to do as much as you can in one layer and just switch when you need to. So again, for cosmetic and other purposes, just gonna put all this down. Just want to make sure that we are in the proper, yes, we are in the proper things. I will correct that in a second, but first, I rather There we didn't need to make it red, but we are already there in the game, so I guess it's good. Okay, we can start placing all the ones in one direction. Let's make it blue. Let's make it blue because we have the other one blue, so let's make it blue. Like again, that's like purely my decision. It could have been either option. It's all right. Okay, so I need to make a red one there for that connection. Good. Perfect. Good. We have that thing done. And now we need to move to the next section. The next section is the EQ section. So I'm really gonna prepare R7 from C7 to C9. So you can see here we're moving far apart from this. So I'm just gonna place this one here just for the purpose of order and having a proper references on where are we going. So yeah. Here, for example, sometimes what I do is that with the larger components, especially when we have some nets below, I just place this one here and I move this one there. So it fits well with the layers below. That will need some adjustment if we have that capacitor there, but nothing possible. Yeah, we're gonna just place that thing there. So we just keep it far away from the connector. So we know that this thing goes from there, and we need to connect C9 there as well. This one might be looking a bit messy now, but everything will make sense in a second. Okay, so for example, now I'm seeing that I think that we are keeping the same axis. That's great. Okay, so first of all, I'm gonna just connect these ones so we have no future problems. The longest net. Great. So yeah, and to keep these things in order as well, thinking how to keep this in the most tight as possible because it would be better if we pass that through the side rather than crossing all the things that we have here. So yeah, I think I will just flip these two. That way we can have that one going there and this one going there, yeah. I think it would be even better if we just flip the order here. It's always better sometimes to prioritize the longer nets to keep them tidy because the shortest one always can be adjusted very easily. But the longest one are the ones who are more problematic otherwise. Tak, dobrze. Now we fix these connections here. And here we are. Great. So we have the EQ section done. We are past halfway through. As you can see, we just did the EQ section and we just need to add the other pump, contour control, and the output section. We are almost there. So, as we can see here, our exit now it's on treble. So, we need to place the other integrated circuit, the other pump. We are gonna place it here, just for having a clear balance. And yeah, we're just gonna construct all this section. So I know that for this area, I need R9, R10, R19, C10, and C11. So one thing I want to fix here actually is that if you remember here when we were doing this part, we deleted R8 for replacing for the mids control. So I think it would be proper to change the name R19 for R8. So then we're gonna have no problems when we're doing the shopping list and shopping stuff, the BOM and all that. So yeah, just keep on placing components. As you can see, yeah, it goes like we know that R8 and C10 are gonna go there on top as a classic figure. We know that R10 is gonna go out of that, so it's good to place it up. Okay, when that happens, it's always good to lock potentiometers because otherwise they're gonna be annoying you. Yeah, I place R10 there because I know it's gonna be the junction for this other section, so it's better to have it there, to be honest. And yes, also I think it would be wise if we just start moving this stuff a bit. I know it looks quite cool to have this in the center, but it's better if we keep the connections tight and close, right? So yeah, for example, I already know that this one is gonna go there to treble. So yeah, I'm thinking how to place that already, right? Like on R3, because it's coming from there from that output. But that's actually quite easy now that I'm saying it because I just need to place that thing there. Yeah, that will be easy. So for that, I will need to fix this part a bit just to make this net to go a bit on the top. I will swap this one for a, I don't need to do that, so I can keep that one blue. Yeah, that would be better actually. If I just this one, there we have it. The connection is perfect. And this one's here. Mm. And actually, if I wanted to, I could just place it outside. Here, like I say, I'm experimenting on the way that many of these nets can be easily redone just in 1 second. So yeah, I like to keep these ones up because big component is always good to have them on the extreme section, so they're not going to be annoying us much. Yeah, so there we have it. Now we need to do this section. This section has a lot of junctions, but we know that we need from R11 to R13 and from C12 to C15. One, two, three, 13. Bingo. As we have some space there, I can place R13 there, but no, it's not convenient. Also, you have to take in mind that later you're gonna have to connect this part. So yeah, keep an eye on that. Don't forget about that. So I think it's wise we already place C16 and R14 there. Hmm. All right. So this looks quite messy now, but don't worry. Everything will be fixed in 1 second. Again, it's good to always look to the schematic to understand what you're doing. So we know that from R10, we need to connect this C15, C12, and R11. And you can always know it better just by clicking here and seeing what lights up. For example, here I'm noticing that it has no sense to have this one there because it's just one connection that could go anywhere else. So that allows me to move all this up and free a lot of space. That's a big plus. And again, as you can see, there are many connections that you can do in many different ways. I will fix that in a bit, but first, I'd rather place all the connections that we need. Okay, so we need to fix that thing here. Good. Okay, this one can go here quite goodly.
Yeah, that part can take forever. But if you just want to build and experiment without the headaches, grab our EAGLE Gerber Pack 300 plus verified circuits, all pre-routed and ready to tweak. Add your logo, change components, and order straight from the factory. Get your lifetime access to the EAGLE Gerber Pack for only $119 at PCBGuitarMania.com. Early bird deal ends November.
Okay, so I think this was the hardest part of this whole circuit design was this one, because as you can see, we had to make a lot of decisions regarding where to place each component and how and where to draw the nets, but nothing impossible really. Nothing impossible really. Yeah. We're gonna fix that one later. Just wanted to make that net disappear. And yes, so we have the volume section done. I mean, like have all the junction till the volume section. And now we just need these output components and the power section, and we are done. So we know that this one will go here. You can place it here. It won't annoy anyone. It will do the job. So, and then we have R15. Here we are. We're almost getting done. I'm going to be connecting these ones here as well. Now, sometimes, like every time I'm finding a misconnection, I'm just executing as fast as I can. For example, okay, I will say that for later. Let's finish the power section first. So, 9 volt, I always like to place it here. And here we are going to start using more grid changes to make everything fits perfectly. I'm going to connect one of those there. I always place a ground next to it, and then the other 2 grounds are going to go right there, top on the other side. As you can see, we have that connection there. So yeah, that's something we have to fix right now. But again, all those are very easy things to solve. Great. I just like to place this one here. Remember, I forgot to adjust the grid again, so you have to be extra careful to put all the components in the right place. You can always uh, go back and just right click. And if you see that it's a multiplier of 25 like this instead of a 50, it's because you have screwed things up. So in that case, you can just adjust all this to here. And now adjust the grid from here. Save. electrolytic capacitors, and this capacitor here as well. And here we are. I'll put this one here because we have a lot of space. With the capacitors, I always like to have the discipline of keeping them all with the positive polarity pointing north. That makes things easier for everything, literally. Here's also good to always look up for keeping the connections close. Good. Great. So we have placed all the components now. So as you can see, we have uh, some stuff that's not connected, and we will need to fix that right now. So the most important ones that are not connected here is the VA. That's our 9-volt equivalent. So we're gonna start proceeding connecting those first. So again, as is we are like in the final stages and we don't need to place more components, I have the liberty of going back to smaller grids just to make things fit properly. Yeah, so you see that there is a lot of things that we cannot do at this time because it's full of paths and connections. And there's always works around that you can do. I'm gonna show you a couple here so we can make things nice and easy. So for connecting this section, as you can see, we have to go and do a very, very long reroute, or we can just simply go here. I'm gonna just make it simpler. You can go here and here till we have to cross these red layers, and we don't want to do that. So what do? We just simply replace, we just click here, go to bottom, and we allow us to add a bias. Now from that point, we allow to go on with a bottom layer. But for making things good, I'm gonna replace this one already for a red one, so we don't need to make any other bias. And now with the bottom layer, I can just go on from here and go straight here. And as simple as that. I try to not use much bias. I just try to use them when they are necessary. Okay, so then we have another missing connection. Same thing, we have it here, we have it with this VA, but here is quite simpler because we can just simply take it from here and it could go straight here and there. But that makes another issue that we have here, that is that these ones are not connected, so it's better if we avoid doing that, at least for now. I will focus on fixing the VA that we have, the VB that we have here, because that will be very easy to solve just with that connection. As you can see, that's done. So as you can see, there are other points that we can connect this power rail, so we can just go up north and then go there, and that's it. It's connected. So now we do a quick error checkup, and as you can see, we have another air wire, and yes, it's the LED that we forgot to connect. So I just go for the bottom layer, so it's the main to go thing, and it is done. We're finally with our design. Just gonna hide the bottom and top layers because I wanna, and also I'm gonna have the bottom place as I wanna do some cosmetics alignment, right? Like for example, here we can see that the gain pot is not properly readable. Here these two are a bit too close, and we're just gonna fix these things to make the best possible layout. We are gonna smash the grounds and we're gonna replace them with the normal text because otherwise we cannot have a component with the same name twice. So we're gonna just select B names GND layer 25, and we're gonna select the size of 40. And we're gonna place it here and here, so we know that those are gonna be GNDs, right? So going back to our layers, we wanna move this a bit up, so we're gonna free the gain. Okay, here we're selecting the gain pod, so we don't have that. Yeah, and we wanna just place them right there. So yes, always when you move components, you will need to run the error checkup again because you're moving the paths, and sometimes the paths start colliding with each other, and that's not good. So I'm just gonna close this thing, and I'm gonna go back to my schematic, open up here, RASNet, ground, and check. No errors. Beautiful. So that's it. The shred master is ready. The final step will be to add the logos. We have a PDF tutorial on how to do that, and now how we're following it. So yeah.
After an hour and a half, we've got one circuit done. Congratulations, but considering all the pedals out there, you might be interested in getting the EAGLE Gerber pack now and save thousands of design hours and focus the most on customizing your own designs into your own creations. Don't miss it. The EAGLE Gerber pack is just $119 at PCBGuitarMania.com this November, with lifetime access included. If you just want to get some of our PCBs, check out our official distributors, dasmusicking.com in Europe, heavymetaleffects.com in North America, and verilygoodpedalco.com.au in Australia. How to add your logo and custom graphics.
First of all, we're gonna go to Google and we're gonna go for the vector we wanna add to our pedals, right? Like for example, here I wanna use Shredder from the Teenage Mutant Ninja Turtles. So I have this image here, just gonna copy it here, and I'm gonna put it on Paint. Ctrl V for pasting it. And then we select the part of the vector that we're going to use. I just want to use this logo here. So I just select Ctrl C for copy, Ctrl N for new. I don't want to save this. Ctrl V to paste it down. And here we have it. So now the most important part is that we need to save this as BMP picture. And we're going to save it as monochrome bitmap. That's very important. So it's going to be only black and white only. And we're going to just call it Shred Marshall vector, because we're going to also have the text variant. Okay, save it. Yes, I want to save it. Now we have it perfect in black and white. So here we have it here. And I have a quite detailed way of doing this, measuring properly the layers and all that to ensure it's going to work at first attempt. But with the years and with experience, sometimes it's faster to just do it the way I'm going to show you right now. You just import the vector. I'm going to go for my PCB paint. I'm going to import it. We always select the layer where the main color that we want to import is. In this case, is black, as you can see here from, we want to import the black section, not the white one. Otherwise, will look weird. So yeah. Okay. Format DPI. Here I always start with a value of between 300 and 450. Let's start with 300. And here the most important thing is the layer that you are gonna use for the current vector, right? Like for example, if you're gonna use layer 21, is the one I normally use. This is the layer that we have here as layer 21 top place. So if I don't want to see top place, this is all the things that disappear. So all the silk screen basically from the top layer. If you want to do it on the bottom layer, do it on import it directly into bottom place. And remember that you have to flip it over though. Okay, so we have that done. Just delete this little thing here, and we adjust the grid as I told you before. Start with the grid of 25. Let's make it visible, and yep, as we can see, this is huge for our model. So now we know that the value of 300 was too big. So we need to go again, import bitmap. We grab the same one again. DPI. Here I'm gonna use like 450, and again layer 21. Right script. Grid 25. I'm gonna delete this little shit here. And almost, I mean, like it's almost there. So we know that we need to keep on increasing number. I like to collect them here. So like I said, I have a detailed version of how to calculate the space and how to do it at first sight. But to be honest, for the purpose of this tutorial and what I've been doing on most of my builds is much more fast. If you just like do some guesswork, it's quite simple to be honest. It doesn't consume much time. So run script. Remember the highest value of the PI you write. Yeah, this is absolutely perfect. This is exactly what we needed. And yeah, we can proceed to delete these previous ones. And the same thing appeals to creating the naming of the pedal, right? Like, for example, here we want to call it Shred Marshall. You can select any typography you want. I always try to go for something that's clear, like this one, not much thought into it. And again, you save it as BMP, and I'm gonna leave it as text, so we have the reference and we understand what is what. Monochrome bitmap, save. Okay, there we have it. Okay, we go back here, go to import bitmap, and as we already have a reference on uh, what's the value, so I'm gonna start again. I'm gonna start with 600 because the text is quite long. Layer 21, run script. Yeah. Okay, so now we have this one is super small, so I know that now we can go a bit crazy. I mean, not crazy, but we can increase the value. So I'm gonna go with always try to remember what was the previous value you used, so you keep track if you how much you need to increase or decrease the value, right? Like for example, this one is quite good, I think. It could be a bit bigger, so then we can go for 300, maybe 350. I don't wanna overdo it. One thing is like once you have standardized which is the type of typography you use and where you wanna have it, this is gonna become something much more easy because you're gonna always use the same values and everything's gonna be much simpler. Yeah, this one is perfect. There you have it. Yeah. Okay, so before I move that, I wanna adjust the grid because otherwise it's gonna be a bit off. So yeah. Okay, I need to adjust the grid to 25 so it fits perfectly. Maybe I can put it here. Yeah, there will fit. And yes, then you add the logo of your brand. That is the same step as I show you. We can put it here or on the other side. It's the same. So we're gonna end this now, and we're gonna proceed for creating the Gerber files. So you can upload this file into EAGLE PCB and order your circuit board.
How to order directly from factory and how to generate Gerber files.
Right, so for creating the Gerber files, it's very simple. Okay, now, first of all, like if you now we are here and we have the circuit done and all that, we can also proceed to add DC drills that we have here. I'm gonna add the proper grid. And if you want to place the drilling templates, you can also copy from the ones we have. Now I'm making this one here, but as you can see, it's very simple to do it. Of course, always use this tool, the dimension tool, so you can measure like, okay, where is the center and where do we go now, right? Like, so because otherwise we're gonna be making things offset, and we don't want to do that. Yes. So as we can see, but anyway, we don't want to do that now. That's just like for you to have an idea. Always measure the drilling template properly. That was just a quick way of showing you. We have a complete document on how to do that. And yeah, so first of all, we're going to start by deleting this thing. We're going to delete the enclosure and we're going to delete also the 3PDT as we don't want this thing to appear on the final PCB design, right? Okay, so here we go to the CAM processor. We're gonna load this layer, this job actually, and we're gonna just click on process job. We're gonna ask if we want to save it. We will save it. This job is also on the attached documents, and you just need to copy it here on this URL that we have here, and it will appear there from on your CAM processors as a job to execute. This is applying for the version of EAGLE 8.2. This is the one I'm using. This one is uploaded on the drive and is the best one by far. It's the most comfortable for me to use. I don't like much the newer version, so I stick with this one. All right, so now that we have this, we will proceed to go to the folder that we have, and here we have all the files that created that export. So these example ones are like trash, and we're gonna just grab all these 13 files that I have here, sorry, 12 files, everything in the folder except the original schematic and the original BRD. Right click, and we're gonna compress as a zip file. Yeah, shred master example in this case. And we proceed to go to JLC PCB. We're gonna check on instant quote, and we're just gonna drag and drop this one here. This will take just a few seconds, and yeah, it will be very straightforward process of ordering. Right, here it is. All right. So what do we have to touch here? Okay, here we have the preview. It's good to check like if you add something that shouldn't be there, like a bad logo or something. I didn't add my brand logo here, but it doesn't matter because it's an example purpose. Okay, dimensions are automatically set, so there is not much more you can do. You can change there. The base material, like for PCB, for guitar products, always stay with FR4. You don't need anything else. All the projects you're gonna be working for guitar pedals are gonna be 2 layers, maybe in one, but always keep it in two. It's better. PCB quantity. This is about you. I mean, like the more that you order, the cheaper you got. Of course, you always have the promotion of 5 PCBs for $2 that we have here, and it doesn't make much sense when you add 10 for 5. So, yeah, the thing is like that's just applied to the first model you order. If you cannot order like multiple different models for $2 per 5 pieces. So, but yes, you can see, yeah, it started getting a bit cheaper, like 30 PCBs for $30 and 200 PCBs for 65. Yeah, 44 start getting cheaper. Of course, then you have to take in mind the shipping estimate, right? Okay, let's go ahead and keep it just on 10 for the purpose of this video. Product type, keep it in consumer electronics. You don't have to touch that. Here, everything basically will stick the same. Like in some cases, if you want to use PCBs for doing faceplates, you can go down with the thickness, but it's the same. Yeah, and the rest you just select the color you want. You have here the preview. And yeah, that's basically everything. Like here, material, you don't need to touch it much. Surface finish, this one is actually good. Um, it's something actually you should take care of it, right? Like you have the standard finish, then you have the lead free, and then you have the gold plated one. The gold plated one is my favorite one, looks the best because it's golden, but it's considerably more expensive. As you can see, if I just click here, yeah, it increased the price quite a lot. For a custom pedal will work amazing. Here you also can choose the gold thickness. And yeah, remember always if you add more units, it's gonna become way cheaper, way cheaper. So it's up to you and it's up to your goals, right? So for standard production, I recommend you to keep things simple, and that's it. So all these other values, you can just keep it like this. It won't make any much more impact on the basic needs that you have as a pedal builder, right? And yes, so this PCB 24 hours express with no extra fee is for assembly. That's for SMD and for when you request the factory to add all the components. So you save to cart, and that's it.
Best PCB factories and special offers.
PCB for all my needs requiring PCB production. But in the past, I have used CD Studio as well, that they have quite some more complex variety of products. Maybe it's more tailored for some applications. And I also use PCB Way in a couple situations where I with JLC PCB was I think on Chinese holiday and PCB Way was available. They are normally all the same regarding quality, but I will always still to stick with GLC PCB. So that has been everything for this tutorial, and I'll recommend you to take a look to the Eagle Gerber files pack. This is the last month for the month of November. We're gonna keep up the sales price, the early bird price on 119 euro for our whole collection of PCB designs, including all the schematic and BRT files, the Gerber production files, the building docs, and anything you need to just download any of our files, add your logo, making some mods in order for making your own pedals. This is the best value you can get and will save you a lot of time because we have basically every pedal you want to build. We already have designed it, so you don't need to do this whole process of learning and designing from the scratch. You should just download and implement it on your own for your own pedals. So that's it for today, and yes, have a great time.